Good afternoon, everyone. Today we're going to be presenting our project on recycled plastic bricks for sustainable construction. This is a collaborative effort by Team 3, composed of Nada Mohammed, Sebastian Vogel. Let's look at what ideas we came up with to address the plastic-based problem for construction materials. Our presentation is structured to cover all of the critical aspects of our project. First, we'll provide an overview of the background and purpose for this initiative in the introduction. Next, we'll outline the project scope and deliverables, detailing what is excluded and included. Then, we'll move on to the schedule, breaking down the timeline for each phase of the project. Following that, we'll review the costs and budget to show how resources have been allocated efficiently. The next section focuses on quality objectives and metrics. This showcases how we ensure that our outputs meet both industry standards and our internal benchmarks. We'll also look at risk management, identifying potential challenges and their solutions. After that, we'll review resource and procurement management to highlight the materials, equipment, and experts needed to bring this project to life. Finally, we'll present our strategies for integration and monitoring, lessons learned, and recommendations, before wrapping up with the conclusion. By the end, you'll see how every element of this project contributes to our overarching goals. Plastic waste is a pressing environmental problem that grows exponentially every single year. Much of this waste ends up in landfills and oceans, heavily contributing to our negative environmental and ecological impacts on this planet, as well as resource inefficiencies. At the same time, the construction industry faces a shortage of sustainable and affordable materials. These two challenges present an opportunity to innovate. Our solution is to turn recycled plastic waste into durable, eco-friendly bricks. This approach not only reduces the plastic footprint, but also provides a practical alternative to traditional bricks, which often have a high carbon footprint. The project is guided by three clear objectives. The first being to develop bricks that are both cost-effective and meet industry standards for structural performance. The second one being clearly demonstrate the environmental and structural advantages of our product through data and testing. And lastly, to build a scalable production of framework that can be adopted by industries and communities alike. Through this project, we aim to showcase how sustainable practices address environmental challenges while meeting industrial needs. Our project scope is focused on creating and testing prototype bricks made from recycled plastics. These deliverables include developing the prototype bricks themselves, documenting the production process in detail for scalability, conducting a feasibility study to ensure the process is both technically viable and economically sustainable, and lastly, preparing reports for stakeholders to demonstrate outcomes and future possibilities. However, we deliberately excluded large-scale commercial production and third-party certifications, as these require additional resources and longer timelines than this initial phase permits. The major requirements for the bricks include achieving a compressive strength of at least 15 megapascals, ensuring thermal resistance of 80 degrees Celsius or higher, and maintaining production costs within 25% of the cost of traditional bricks. These align with the industry standards and will be used as a reference through all phases of our project. The project timeline is carefully structured into 5 distinct phases to ensure systematic progress. Initiation, weeks 1 through 2. During this phase, we define the project's goals, scope, and stakeholder roles. This step lays the foundation for all subsequent work by aligning everyone with the objectives and deliverables. Planning, weeks 3 through 6. This phase focuses on creating a comprehensive project charter, allocating resources, and establishing a detailed timeline. The planning phase ensures that the team has a clear plan for success. Execution, weeks 7 through 9. In this phase, we move into action by sourcing materials, designing molds, producing prototype bricks, and finally testing. This is where a majority of the hands-on work is going to take place. Monitoring and control, weeks 10 through 12. Here, we'll track the project's progress against the plan, analyze test data, and ensure quality objectives are being met. This phase is crucial for identifying and resolving any deviations. Closing, weeks 13 through 14. Finally, we'll consolidate all findings into a final project report and prepare for the stakeholder presentation, marking the completion of the project. The total budget allocated for this project is $40,000. This amount covers essential expenditures such as sourcing recycled plastic feedstock, fabricating molds, procuring equipment, and paying for labor. A contingency fund is also included to handle any unforeseen challenges. Key cost-saving measures have been incorporated to maximize resource efficiency. For example, we're using affordable recycled materials to keep raw material costs low. Additionally, the team has worked on optimizing the material usage during production to reduce waste. This approach ensures that the project remains financially sustainable while still meeting all its objectives. The careful allocation of funds reflects our commitment to achieving cost efficiency without compromising quality. Quality is a cornerstone of this project, so we set specific objectives and metrics to ensure that the bricks meet both industry standards and our internal benchmarks. Our objectives include achieving compliance with the ISO 9001 standards and using at least 90% recycled plastic in our production process. These goals reflect our commitment to sustainability and excellence. To measure success, we track metrics such as compressive strength, thermal resistance, and a defect rate of no more than 5%. To ensure we meet these metrics, we have implemented control mechanisms such as continuous testing of samples, peer reviews of our processes, and statistical process controls. These strategies help us maintain consistency and reliability throughout the project.
For risk management, we identified 3 key risks. The first was variability in the quality of recycled plastic feedstock. Since we rely on waste plastics, maintaining consistent quality presented a significant challenge. The second risk was delays in mold fabrication. Custom molds were essential for our prototype, and any delay in this area could cause a ripple through the project timeline. The final risk was stakeholder resistance to adopting a new material for construction, which we anticipated due to concerns about performance and durability. To address these risks, we implemented several mitigation strategies. For feedstock quality, we planned for alternative material sourcing to ensure continuity. Regular vendor communication helped us mitigate delays in mold fabrication, and early stakeholder engagement, such as meetings and demonstrations, allowed us to build trust and address their concerns effectively. By proactively managing these risks, we minimized disruptions and ensured the project stayed on course. Our procurement needs included 3 key elements: recycled plastic feedstock, molds for brick fabrication, and high-precision testing equipment to validate our prototypes. Each of these had specific sourcing requirements to align with our budget and quality goals. On the human resource side, the project team was structured with clear roles: a project manager to oversee progress, material engineers to design and refine the bricks, and a quality assurance team to validate performance against standards. To manage these resources effectively, we adopted a structured approach. Weekly reviews allowed us to monitor progress closely, and milestone-based incentives kept the team motivated and focused. This strategy ensured that both the materials and human resources were utilized efficiently, helping us deliver the project on time and within a budget. Integration and monitoring were key to ensuring all aspects of the project worked cohesively. We used a centralized project management platform, ClickUp, which allowed us to track progress in real time. This system integrated all project components, including scope, schedule, cost, quality, risk, and resources into a single framework. To monitor progress, we held weekly alignment meetings to address potential delays and reallocate resources as needed. Dashboards provided visual insights into task completion, resource availability, and quality metrics. For monitoring, we utilized tools like earned value management to evaluate cost and timelines, and statistical process controls to ensure quality consistency. By integrating these components effectively, we minimized disruptions and ensured that the project stayed aligned with our goals and deliverables. As with any project, there were valuable lessons learned and opportunities for improvement. One major lesson was the importance of early stakeholder engagement. By involving industry experts and environmental advocates from the beginning, we reduced resistance and gained valuable feedback that improved our prototypes. Another lesson was the benefit of proactive risk management. Addressing risks such as feedstock variability and mold fabrication delays early on helped us avoid major disruptions. Looking forward, we have a few recommendations for future projects. First would be experimenting with alternative additives which could enhance the performance of our bricks, especially in areas like compressive strength and thermal resistance. Second, partnering with local authorities could facilitate broader adoption, making it easier to scale the project. These steps will not only improve the product, but also increase its market feasibility and environmental impact. To conclude, the project successfully developed brick prototypes that met essential structural and thermal benchmarks, including compressive strength and resistance to high temperatures. We achieved cost efficiency by using recycled materials, which reduced manufacturing expenses while maintaining quality. Additionally, positive stakeholder feedback validated the product's feasibility and sustainability potential. However, there were challenges. The quality of recycled plastic feedstock varied, which affected consistency. Additionally, gaining confidence from stakeholders who were unfamiliar with our materials required significant effort. Overall, the project has demonstrated the potential of recycled plastic bricks for sustainable construction. In the future, we suggest integrating AI tools for production monitoring, experimenting with additives to enhance material properties, and partnering with local authorities to expand the product's adoption.